what's a linear equation? Most textbooks will describe it as, it's merely something that looks like this, simple. AX plus B is equal to 0. Solve for X. Now just want to tell me in AX plus B, and then once you get the X by itself and solve for it. Please, at this point, the simple linear equation, what would you suggest I do? Solve it. I don't have numbers in this one. I've got A, X, and B, but what would you do with an attempt to solve it and get the X by itself? I think just describe this as a linear equation. I think the first thing you're going to do is move the B over, subtract it, and then do what? Divide both sides by A, where the A's cancel, and all they want is please get that X by itself. So that's my solution. Now you say, Professor, what does that mean for me? Well, that means you could, which you more than likely would not have something this simple, but you could have something like a linear equation that looks like that. 3x subtract 12 is equal to 0. Solve for X. Almost the same procedure I used on the AX plus B, that general form there. Of course, you want to move the 12 over, add it. Divide by 3. We'll get all the simple stuff done today. And X is equal to 4, and you're finished. Done. Please tell me at this point, the first quiz, I want to see a 10 out of 10. Would it be helpful if I gave my equations like this? Just write this 3x minus 12. Solve for X. 5x plus 2. Solve for X. 9x subtract 7. Solve for X. Should I create my quiz using those types of equations? Wouldn't that be nice? That would be super nice. Now, are they going to look this simple? No way. But are they going to still be a linear equation? They can't be. Now, what I'm going to do here is, I brought some things in here, guys, to see what's going to happen here. Is this. I need some help here. If you're asked to solve this, separate it, put it down here. 4 times x plus 6 equals negative 2 times 3x subtract 1. Solve for x. Now that does not look as easily done as my first 2 were, but I'm cleaned up. Now, I know some of my students have been away from, I guess, for a while. They've been away from factory, distributed properties, and so forth and so on. As soon as we start working on this, I guarantee you, a lot of this will come back. Guys, on this one, let's use the distributed property, multiply through by 4 on the x plus 6, and quickly change this into 4x plus 24. That's done. The other side, let's distribute the negative 2, and if I do a multiplication, you end up with a negative 6x. Be careful here, a negative times a negative turns that into a plus 2. That's just distributed property. Just clean it up. Now, by the way, at this point, is it going to look more like what I just did above there for the simple one? It is. It's looking more like it. Now, to complete this and solve for x, you got to get the x's together. So if I move this over by adding 6x, guys, you're going to end up with 4x plus 6x is 10x. That's no problem. Move the 24 over by subtracting 24. Help me out there. What should I end up with if I move that 24 over by subtracting and then combine that with 2? What should I end up with? Okay, is that negative 22? Move it over? Is that true, guys? Now, to finish it up, you'll say, wait, Professor, that actually turned into a linear equation. 10x is equal to, in this case, negative 22. Last step, divide by 10. These cancel, so x is equal to, and guys, negative 22 over 10 is not a nice number. Can it be reduced down?
Negative 11 over 5.
There you go. That's all I need to hear. A negative 11 over 5, and you're finished. Now, those are the most simple equations I could throw at you on the quiz on Wednesday. they result in a linear equation. Now, part B, a little tougher. Put this in green here. What happens if it's not a linear, it's one of these? A quadratic equation. And guys, I'll give you the form that most textbooks give for a quadratic. Ax squared bx plus c is equal to 0. Now what's the difference in the linear that I just finished up and the quadratic? The highest exponent over here on the quadratic is a 2, which indicates I need 2 answers. Now linear, I just have 1 answer. Now if I go up to a cubic later on and see a 3, I gotta get 3 answers, 4 answers. This one has only 2, there's known as quadratic. And for an example, if you're asked to solve this. I brought something all mixed up here. Beautiful. X squared, subtract x, subtract 6, is equal to 0. Just a little quick review. That's a quadratic. Now on the side here from last week, we have options. We may factor to find the 2 answers. And I realize sometimes students, and myself when I was a student, my factoring skills at first were not that great, but factoring will work. If factoring does not work, and I do not insist that you factor, you could turn to this, the quadratic formula. Guys, and point out again, like I did last week, what that formula looks like. Negative b plus minus square root b squared subtract 4ac all over 2a. Now, before I jump in, that's 2 options. Solve a quadratic. Does anyone think of another way to solve a quadratic that maybe I haven't mentioned in class? To get the 2 answers, besides factoring or using the quadratic formula. Can anyone think of another method that maybe you've seen somewhere to solve a quadratic? Go for it.
Completion of square.
Now, completion of the square. I will throw that in. That's the tough one. There's a process called this. Completion of the square. Unusual technique, but needed. Completion of the square. And can someone tell me maybe one more method? I haven't even shown you completion of the square yet. Besides factoring, besides quadratic formula, by the way, this quadratic formula, I love it because it always works. It always works. So if I do not insist that you show me factoring, you can turn to the quadratic formula to solve all these quadratics. It always works. Completion of the square, which I haven't shown you yet, it's a little lengthy, but I can think of one more method myself to find the answers. Can anyone tell me what you think it is? Factoring, quadratic formula, this thing called completion of the square, and I can think of one more way that maybe you can find 2 answers for, and we'll come back to this and find it, the 2 answers for that quadratic. Go for it.
Difference of squares.
Sure again.
Difference of squares.
Difference of squares may come up in the process. That's not one of the techniques. Suppose I did this for you. Number 4. Suppose on the quiz exam, I am nice enough, and you go out and say I have the nicest professor. Oh my goodness, what's the EPA? And all of a sudden, I show you a graph of, a picture of a quadratic. What do all quadratics graph into? Linear graph into a straight line. When I look at linear line, I see the word line in linear. It's a straight line. How about a quadratic? You should know that by now. What is it? What do all quadratics, if you have an x squared, what's the shape, its graph, what's the shape of the graph of a quadratic always? And there's a name for the curve. It's a curve. It's not a straight line. Does anyone remember the curve, the name of it? parabola. So if on the quiz or the exam, I provide a sketch for you, and all of a sudden you say, Professor, how nice. A parabola. That's the way the shape looks. And all of a sudden I look back here and maybe I do this. Real quickly. I say, okay, class. That parabola is going to cross the x-axis at 3 there. And it's going to cross the x-axis here at -2. Suppose I, as a professor, would show you a picture, a graph of this. X squared minus x minus 6. And there it is. Now please tell me, if the graph is provided, what do you think the answers will be if I were to graph it for you? What do you think the answers right here would be quickly? And you don't have to use this, you don't have to use this, you don't have to use this. If the graph is provided, what do you think the answers are? Why is the graphing so nice if I provide a graph for you, a parabola? What are the answers? Guaranteed for this quadratic. Without going through factor. No quadratic formula. No completion of the square, which I haven't mentioned yet. What are the answers? Look at these 2 points where it intersects the x-axis. What, -2, and what was it? +3. The professor really, can you be finished? Those are the answers, Professor? And there should be 2 answers. Now, would it be nice on Wednesday if I did this for you? Then on the side of the equation, I'll say, this is its picture. This is what it looks like as a parabola. And mark it for you. Would that be nice, though, if I say solve it, could we quickly just look at the x-intercepts they call them? Those are the answers. Now, do you think I will do that? I may. Just to see a smile on your face Wednesday. As you're taking the quiz, you may look and say, oh, you did it. I may do one for you, where I actually graph it for you and say, now solve it. And you missed that one, I'm going, ooh, if I provide the graph and you can't tell me where the 2 numbers are and those are the answers, we need to talk. Now here goes though, in case I do not provide a graph for you. Let's go back. Can I get those same answers by factoring? Guys, now the x squared subtract x subtract 6 in the green. I'm gonna bring it over here. It will factor. Now factoring skills are skills. We'll do this to get you started, to give you a hint on what I want. I want someone to help me fill in those parentheses and show me x squared subtract x subtract 6 in factored form. And I'll get you started. It's got to be an x and an x in the first 2 spots. Gotta be. Now, what should go inside there? There's more. Well, what goes inside is, now I'm looking for 2 numbers on the end. I got the beginning x squared out of the way. What 2 numbers on the end, when multiplied together, would give me a -6. Oh, let me get those out of the way first. What 2 numbers multiplied together would give you a -6? -6, 1. +6, -1. 2, -3. Let me squeeze this in. 3, -2. I think those are the only possibilities of numbers multiplied together to give me -6. Now, which of those pairs should I choose to put in those parentheses and finish this factoring up? Well, I want in the middle what number? What's understood to be the number there that I'm seeking for the middle? -1. So there should be a 1 here. So which of those pairs, when I put them together, will I get -1? If I put these 2 together, that's -5. I don't want that. These 2, that's a +5. There's no 5 over here. These 2 put together, what's a +2 and a -3 combined? Is that -1? If you put them together? And that's exactly what I was looking for. Therefore, right now I know which pair I need. I need the 2, which you can write this as +2. Right there it is, and a -3. And there it is, factored. So if your factoring skills are a little, not too good, you can always do what I did on this one. Guys, there it is, factored. Now, if you factor, you're allowed to split this up, especially since you have a 0. you're allowed to set each one of these factors equal to 0. And solve. You guys, when I say solve, it's merely move that 3 over. Let me erase this so I got some space. Move that 3 over, you're going to end up with a 3. Here, move the 2 over by subtracting, you end up with a -2. Please tell me, did we say those were the answers earlier? When I graphed? Got the same answers. But this time I use factoring. Now, suppose you're saying, oh, professor, no. Are you going to ask me to use quadratic formula, professor? If I do, I should get the same answers. Now, I myself love quadratic formula. I just go ahead and just plug in the numbers, the A, B, and C, and work it out. Guys, quadratic formula, let me check and see if it'll work here on this one. First, let's identify the A, B, and C. The A is 1. There should be a 1 there out front. B is a -1. Constant, C, is a -6. If I'm patient, put those into my quadratic formula, I should get the same answers. Here goes. Starts out with negative, and then B. Well, B has been identified as -1. That's my B replacement. Plus minus square root. Now I got B squared. That's -1 squared. This says subtract 4 times A. A is 1. Identified earlier. C, identified as -6. Switch that here. And all that's over 2 times A, and I think we identified A as 1, so it's 2 times 1. Just plug in the numbers into the quadratic formula. Now if I'm patient and don't make any mistakes, I should get the same 2 answers I got earlier. Let's see if I do. This turns into a +1. No doubt. Plus minus square root. Most of my students who do remember the quadratic formula, they make mistakes underneath that square root. Guys, this much right here, -1 squared is 1. -1, no, it's -1. The other part remaining is where sometimes we'll mess up. I'm talking about this remaining part there. -4 times 1 times -6. What is that product that's left over in the black there? -4 times 1 times -6, altogether will give me what? Positive 24, I think it is. You got positive 24. And all that's over 2. Can I simplify this? Of course I can. 1 plus minus is the square root 25, all over 2. By the way, does 25 have a nice perfect square root? Thank goodness, 5. So I can write this as 1 plus minus 5 over 2. Separated? One answer will be 1 plus 5 over 2, and I'll come back to it. And the other one is 1 minus 5 over 2, and I'll come back to it. And see what happens here. Guys, the first, of course, is going to be 6 over 2. 3. This one down here is going to be a -4 over 2, -2. Please tell me, are those the same 2 numbers I got back here? How can you go wrong? Number on your paper, if you missed one of these, I said you went wrong. How can you go wrong? So we got quadratic formula, we got factoring, and then we have this graphing, which I graphed for you right here, to find the answers. Now, I have not, and will not, probably will not discuss this today, the completion of the square. I'll hold off on that till Monday. Okay, no, Wednesday, for a lecture. It will not be on the quiz. I'm just testing the basics. I mean the basics on the first quiz. Are we okay now? Now, can I use the quadratic formula? Here it is. There's no problem. May I use it on an equation that looks like this? No, these are not quadratics. These are linears. Now, I can use quadratic formula on linears. I've seen some students try to. No, this is reserved only for quadratics. So we're done. Okay, we got that part B, we got 1, we got factoring, quadratic, linear. I'm going to go into part C here. Part C. Guys, I'm gonna label it like this. Others. Other equations. What could they look like? I brought some in. I need your help. Beautiful, beautiful, beautiful. Just 1 second. Here we go. When I say others, let's try to solve this. X squared minus x. And I'm looking at it. Subtract 7 is equal to 0. That is a quadratic. Definitely. Now, I think I tried to factor it last time, didn't I? And it factored out nicely. Can someone tell me right quickly, do you think this one, if I attempt it, will factor? That's the issue. Some quadratics will not, flatly will not factor. So what does one turn to? You have no choice right now. You turn to this. If it's not going to factor, all you have right now in this class is the quadratic formula. Unless I give you the graph. I'm not going to give you the graph here. So guys, I'm going to go directly to the quadratic formula and show you why I identify this as another type here. By formula, x is equal to, it says negative b. B is understood to be a negative 1. I better point out, a is 1, b is negative 1, c is negative 7. If I carefully put those in, negative b plus minus square root b squared, negative 1 squared, subtract 4 times a is a 1, c is a negative 7, all over 2 times 1. I'll step back and look at it. Are those numbers put in correctly? I'm not on top of the board. Are they put in correctly? Now, when I finish this up, best I can, when x is equal to, that turns into a positive 1 out front, negative times negative. Guys, underneath that square root, then I see a 1. Then all this on the end, is that a positive 28? So let's go first, is that positive 28? So I got 1 out front, then plus 28 for the end, all over 2. And you end up with 1 plus minus square root 29 over 2. Please tell me. Last time I did a square root, it was a square root 25 and everyone smiled, it's perfect, fine. This one came out to be, if I made no mistake, square root 29. Is that a perfect square root? No, so I can't do anything to it. I gotta leave it. It won't even break down. So you say, Professor, what are the answers? That's why this one's strange. The answers are, when I separate these, one answer looks like this. And the other one looks like this. Those are your answers. So you might end up with some strange answers when you do it by quadratic formula. All depends on that square root there. And I'll look at it, make sure I separate these correctly, looks like they are separate. Now, under others, here's what my students, I typed something like my students in the 4 o'clock session were concerned about from homework. They said, Professor, suppose you give me this. K here rather than X. Just hold up the variable there. It's equal to K subtract 7. Solve for K. Now, why would I put this under the category of other types of equations? Right now, it looks nothing like a quadratic. It's definitely not linear. It has a square root. What might you have to do first if you see a square root staring at you Wednesday? In the green here, to solve for K. What are you going to do first? You're going to factor? No way. You're going to use quadratic formula, it's not a quadratic. So what are you going to do? You're stuck. So I'm going to give you a suggestion. I had some of my students in the 4 o'clock session. fact, I think we did this problem before last session. We're going to undo that square root by doing this. We're going to square each side. That will undo that square root. In other words, the square root's going to drop off, which I like, and leave me nearly that. Done. Right hand side, though, you've got to square it also. Can anyone tell me without me taking the time to expand that thing out? What is k subtract 7 times another k subtract 7 going to give you? I know some of my students know it. I'll give you k squared. Does anyone think they know it without me multiplying it out? K subtract 7 times k subtract 7. We'll start with the k squared. And what else?
Minus 14.
Thank you. Minus 14k. And?
Plus 40.
Thank you. Now, what has that turned into? What type of equation now is it? Quadratic. Now I'm back into factoring, quadratic formula, takes me right back. So guys, before I jump in and decide whether I want a factor or a quadratic formula, let's clean this up. Let's move the k over. Let's move the 1 over. Gotta have one side to be 0. We've got k squared. When I move that 1 over by adding, guys, I think, was it adding here? K minus 1? Add. I ended up with what, negative 13, was it?
Negative 15.
Was it negative 15? Did we have a negative 15 in the session at 4 o'clock? Okay, let me check and see if everything's good. Okay, everything's good, k squared. But, looks like if I add, move the k over, minus 15k, that's what you guys are looking at. And if I move the 1 over, was it plus 50? I'm trying to recall what we did downstairs. It was, wasn't it? K squared minus 15k plus 50 when you move things over and put them together? Yes, no? Right here, I move the k over by subtracting. So that means we got now negative k there. That's how I got that. You move the 1 over by adding 1. That's how I got the 50. Is it true? Now it's a quadratic. Now it's up to you. I may just say, now do it the best you can. You may use quadratic formula, you may factor. To save me a little time tonight, I think this one does factor. And some of my students do have some strong factoring skills here. Guys, can anyone think of the pair of numbers I need here? Because I need a product to be 50. But the numbers must add up to a negative 15.
Negative 5, negative 10.
There you go. So k minus 5, k minus 10. Absolutely. Split this up. You get to set each one of these equal to 0 since you have a 0 on the other side. So 0 product property. And we solve this right quickly. We end up with k to be at 5, k to be equal to 10. You say, Professor, how cute. So the green has for answers 5 and 10. Did we do it correctly? Then you walk out of here on Wednesday, and I noticed some of my students, I've been doing this a long way, when you walk out, you may ask someone else to do it in the class, what'd you get for number 3 on that quiz? Oh, I got this. And I hear them students outside talking, especially in my winter class, I could hear them out there. After a test, they were all talking about, what'd you get for this one, running this test? What'd you get for this one? And then after everyone turned the test in, they come back into my room before I left. They ran to me, Professor, please, what was the answer for that one? I said, what'd you guys get? Oh, I got maybe 3, but he got 5. And she got 10. Now look at it, all 3 of you are wrong. Well, I got the right answer. Now, suppose on your quiz Wednesday, you have one of these. And you got this, and you walk out and you feel very comfortable with that. And all of a sudden, you get your quiz returned to you, or you might see your score the next day. Because I score my quiz fast. That's on camera. You might see your score on Thursday. And you can see, oh, goodness, I thought sure I got 10 out of 10 on this quiz. And I got like a 9.5 out of 10. Tell me what could have gone wrong on this last one, where you could have lost half a point.
You have to try them.
Very good.
You have to try different ones.
Okay, these 2 numbers here, I have not been doing checks on the others. a check is critical, especially on an equation that contains a square root. You've got to test. These numbers right here may not work. I may have done all this work here. 5 may not check. 10 may not check. Maybe one of them will check. I don't know. So I will point out on the quiz, I'll have a little space on the quiz for you to show me the check. So make sure we do have an answer. Guys, we'll check first, let's check 5. Is K equal to 5? If I am patient, go back to the green, put a 5 in, and we end up with square root 5 minus 1 is equal to 5 subtract 7. That's what the original green would look like, K being a 5. I think this is 4. Square root 4 is 2. The other side is 5 subtract 7. What's that? Negative 2. Are the two sides the same? No. Let's see. Hold on. This has to be rejected. Now don't get angry with me on Wednesday if you have to reject both of them. And you've already done a half sheet of paper to get the answers. Maybe one has no solution. I've got to test 10. 10 may not work. I don't know yet. Okay, guys, let's try 10. I'm patient, put 10 into the green. I end up with square root 10 subtract 1 equal to 10 subtract 7. I think it's a 9 underneath there. Square root 9 is 3. 10 subtract 7, last time I checked it also, 3. Okay, the only answer is 10. Now, I will alert you to something like that. I'll have a little space on the quiz to just check. Make sure you check this one. So far, so good? Look at the time it's taking me just to do a recap on all this. Under others, I got strange square root. I did a square root, quadratic was strange. Did a square root with a K in it. Seems like there's one more I'm going to point out what I need is. Yes. There goes. The last one. Number 3. Under the others, I'd like to solve this with some input from you guys. It looks like this. 2 over x subtract 2 equals 3 over x plus 5 plus 10 over x squared plus 3x minus 10. Looking good. This is the last type I'll try. After this. Guys, any ideas? Now, if I have one like that, so you hang one up. But first, before I jump into it, can anyone tell me, the whole class should be able to tell me this, can you tell me by just mere observation, what can I not let X be in case I get it, I have to reject it? Can you look at it right now, the way it looks, and tell me what can X not be? For sure. Just the way the equation looks. So if you get that number, professor, you gotta mark it out. If you get that number, professor, you gotta mark it out. Does anyone see there are 2 of them? 2 numbers there that if I should get them when I finish up, they've got to be rejected. I see, hang one up, yes.
2 and -5.
Okay, positive 2, she's telling me, professor, if you get 2, you gotta mark it out. And she's telling me -5. Now, can you give me the rationale why? Why can I not let X be true?
You can't divide by 0.
You can't divide by 0. You go back and put, replace X by 2, you're gonna get a 0 denominator. And you never have a 0 denominator. I think you'll get a 0 denominator also if you replace X by -5. So if I get either one of those, you can accept them. And the sad thing is I'm gonna solve this thing. Well, it'll be a little lengthy. The sad thing is, suppose I get both of them. Then the answer's no solution. Now, let's see what the solution is. I cannot let that happen. Guys, step one, can anyone give me a suggestion on something that you see right now to get me started?
Greatest common factor.
Come again.
Greatest common factor.
Greatest common factor, I like that to be more.
Well, x minus 2 and x plus 5, that's factored. That's on the right, that's it factored out.
Look at this, x squared plus 3x minus 10. She's a professor, I know how to factor. She says this, if it would help, will factor quickly into this. X plus 5, this is factoring skills. X subtract 2. Everyone agree? They're just factored. Then she's being very, very, very smart here. She says, wait, Professor, when I look at the denominators of the other two remaining fractions, I see that x plus 5 shows up here. Underneath this one, it matches up. And the x subtract 2 she gave me is going to match up here. So everything looks like it's matching up for me. Now, that's my, I'm going to call it the least common denominator. Let me use these initials. The LCD, a common denominator. I like to call it the least. It's a common denominator. Guys, I need a common denominator to do this, of this. X plus 5, x subtract 2, so I'll cover both. You gotta use both of them, x plus 5, x minus 2. Now you say, what are you gonna do with that now since you've already discovered that common denominator that you need, Professor? Lots of things I can do here. Guys, tell me in the green here. Underneath here for my denominator, I have what right now? In the green, x subtract 2. What would I like to have all of them eventually have down there? This. So what's missing here that I will have to put in if I want this underneath that first fraction? What's missing? I got the x subtract 2, but what's missing? If I want this, I got to put in x plus 5. I put it in there, I got to put it in the numerator. Now it has my common denominator. When I check out my next fraction, it has the x plus 5. I want it to have this, my common denominator for all of them. So this one's missing the x subtract 2, I've got to put it in. And here. When I move over to the other side, the 10, does the 10 have it right now? Is there anything missing on the 10? No. It has the common denominator right there. It is staring at me. It has it right now. So nothing to be done there. And I said, Professor, what can you do? After you get them all over the same denominator, then you tell me that, Professor, then this, and this is all I need to worry about. I just need to worry about the numerators. Does that make sense? If all the common denominators, I just need to worry about the numerators. Now on top of this one, be careful, I got 2 times x plus 5. That will give me 2x plus 10. Right, make it up. On the other side, an equals. Up here, distributive property is 3x subtract 6 in the numerator of that fraction there. The 10 is all by itself on the last fraction. That's all I have left. Make sense? All my denominators are common. Now, guys, I need to solve this, and to solve this, that takes me all the way back to, in this recap, this. That's a linear equation. It's not quadratic. We looked at here, we've got a linear equation to solve, which is one of the easiest ever. Guys, to solve it, we can clean it up a little bit. This is 2x plus 10. This marker will continue to work for me. 2x plus 10. And on the other side, collecting like terms, and maybe 6 plus 10, that's a 4, I guess. 3x plus 4. Let's clean that up. Now solve for x. Get the x's on one side, like we should for a linear, and solve for x. Guys, it's up to you, but I'm going to move my 3x over here by subtracting. You're going to end up with a negative 1x. I'm going to move the 10 over here on the other side by subtracting. 4 subtract 10 gives me a negative 6. Right on top of the board, make sure I move things around correctly. I think I did. Divide both sides by a negative 1. What's my final answer? of 6. For that crazy equation. 6. Now I'm gonna show you a real quick check to see if 6 surely does work. But by the way, what is 6 that came out? Was it one of those numbers that we said we could not use? No, so it should be okay. But since I'm gonna close this down, we'll just quickly throw out check and see if I made a mistake. See if 6 works. Guys, I'm gonna check here. Here goes. Does 6 really work? Professor, let's check it. Guys, go back to the original green. I got 2 over. Replacing x by 6. 6 subtract 2 gives me a 4. Like that. On the other side, in the original green, you got 3 over 6 plus 5. Replacing x by 6. And plus 10 over, and I'll get out of the way here, guys. Now I gotta put a 6 into the green here. Be careful. Replace that x by 6. 6 squared is 36. Gotta help me out. 36 plus 18. Is that true? 3 times 6 is 18. So 36 plus 18, how much is that right there? Is that 54? And then subtract 10 on the end, is that gonna give me a 44? Let's replace the x's by 6. I hope this checks. Okay, see if it does. Guys, on the left, I've got 2 over 4. I got 3 over 11. I've got 10 over 44. Now that's my check part. It'd be really sad if 6 does not check. But it already says. Guys, 2 over 4 is 1/2, of course. Now, I'm hoping, you're hoping, that when I put those 2 together, I also get 1/2. Which means it checks. 6 works. To put 3 over 11, 3 11ths, and 10 over 44, oh, by the way, would 10 over 44 reduce down? That fraction 10 over 44, would that reduce down maybe what, by 2? Help me out. Is this the same as, I'll go right here. Is this the same as 5 over something? Help me out. 5 over 22. Okay, you can reduce down if you wish. Now, how am I going to now put those 2 together? Fractions. Elementary school, when that elementary school teacher smiled at you. Remember back in the day when the teachers were so nice to you? Oh, they were so nice. They smiled and pat you on the back and said, oh, you're the greatest. What'd you do next? I think you're going to try to put these 2 together with a common denominator. What would you use for your common denominator? If there's no mistakes so far. You got 11 and a 22. What would you use that? 22? So that means I need to multiply this one by what? 2, if I want at 22 down there. Guys, that gives me 6 plus 5, 11 over 22. Which is what? It checks. So that's 6 checks. Whoa. It's going to be so interesting to get to know you guys. It's going to be interesting. Because I guarantee, I don't give you, I guarantee, many students in this class will say, oh my goodness, thank you, Professor, this has come back to me. I remember some of this, and others will say, ooh, Professor, I didn't do too well in high school algebra, I didn't do too well here, too well there. This is a little bit of a challenge for me, and no matter what, whether it's going to be a challenge for you or it's coming back to you, we got to do it. Guys, this is all I'm doing. Okay, solving equations. Now, the part of the quiz where it says solve, it could be a quadratic. And I may give you the choice of what method I want you to solve that quadratic. I say, make sure you show me quadratic. If not, you get to factor if you want to factor. Or I guess I don't think you want to go down here and try to graph, not yet. Others, I love those with square roots. The 4 o'clock session brought in a nice one. It had 2 square roots. And it took us maybe, what, 15 minutes? to do that one problem. So I doubt if I give you two square roots on quiz. I think one square root's will be enough. Okay, so guys, quadratics, linears, and then others, maybe a square root, maybe something with, this one right here with fractions. We had to come up with a common denominator, put all this business together and solve it. Okay, that's the types of equations. Any concern? Now, I have not seen you since what, last Wednesday? So I don't think Thursday and Friday and Saturday and Sunday, you were walking around thinking about the quadratic formula. I'll just get a sense of no. When I was in school myself, I don't know. Those days were off days for me, So we did a recap to get you back into it. Okay. Now, with all that said though, I got 10 minutes here to introduce this. Here we go, the other part of the quiz. Is this. Let me just get a start. Here we go. Let's call this, I guess, part 2, part 3. We put part 3 down, I think it is. And that's this. Solve. Now, on the side here. The last part for the quiz. Solve now these. Known as inequalities. Not equations, inequalities. Before I jump into some examples, greater than guys, here goes. If I should show you a quick example, if I say x is greater than 4, I know and you know, he's talking about all the numbers to the right of 4, not including 4, so it's open. Didn't include 4. And all the numbers to the right of 4 definitely are greater, so here's the sketch showing x is greater than 4. No problem. Now what do I want though, when I finally start to solve some of these? I want this expressed in something called interval notation. Now, does anyone recall at all anything about when the textbook says, please express this in this? Does anyone have an idea what x greater than 4, I see this picture, what that looks like in interval notation? Does anyone remember anything at all about interval notation? I think you do, maybe you just don't want to speak up right now. 4 is not to be included. So they want you to show for 4 here, a parenthesis, place 4, and then how far out does it go? Forever, indicated as infinity. And it's close it up. All that's saying the same thing. 4 through infinity, parenthesis 4, comma infinity, goes forever. That's what my graph does, it goes forever. Starts at 4, does not include 4. So that's interval notation. If I did this though, let's write another one here. Let's write this as x is less than or equal to -2. Visually, it means this. Place -2 here. And guys, this time, and someone's going to give me a reason why, I get to color this in, it's darkened in, it's not open this time. Why would my starting point in this case be darkened in? Because they threw in an equals marker on this one. So it couldn't equal -2. To show less than -2, a little common sense, to the left of -2. Get all these things done tonight. And that's the visuals, that's the way it looks. Now how's that look in interval notation? Well, it's going to the left forever. So we'll write this as parenthesis, negative infinity. But the thing sign says it's going to the left forever. How far up does it go? It goes up to a -2 and it stops, and it includes -2. When it does include, you go up to the bracket, not a parenthesis. If that -2 is to be included, you go up to the bracket, and that's the interval notation to show this. I'm throwing another one, you guys. Let's try maybe x. Looks like this. Now, when you do a visual here, to show first. Guys, that says, if you take a close look at it, x is caught between -1 and 5. -1 cannot be included. 5 can. So visually, you got this going on. You got -1, we'll go up to a 5. -1 cannot be included. 5 can, so it should be darkened in. And guess where I shade on this one? To the left, to the right, like I did on the first two? No. Look at it closely. Where should I shade in to show visually what does this mean? It means all the numbers caught between what? -1 and 5. I have no choice. Here's the answer. It means caught between -1 and 5. -1 can't be used, 5 can. That's the way it looks. So we got a greater than, a less than or equal to, and something called in between. And interval notation here, be careful. Put it in here, guys. Someone may know what it looks like. Does anyone know what this may look like in interval notation? We'll start with the parentheses. And have what? -1 up to 5 where it stops, but it can be included, 5 can be included. We'll put a bracket. That's called interval notation. Check my time here, got 5 minutes ago. Use my time wisely here tonight. Okay, guys, just a quick glimpse of what's going on here with the interval notation inequalities. Now you say, Professor, why are you going to do on the quiz? I'm going to do this. First, I'd like to find this. Beautiful. Right. I'd like to try this. Solve this. And it's going to be an inequality, not an equation. And it looks like this. -2. Let's call it x plus 3. And I had along with that, less than 8. Solve for x. Much like an equation. Much like an equation. Distribute property on the left, distribute the -2, you'll quickly get this. That's no problem. Much like an equation. Move the 6 over by adding, no problem. -2x is less than, looks like 14. You add 6. What's my last step? Much like an equation, what would you do for the last step? Divide by, both sides by, -2. These will cancel, we get x. The other side's a -7. Anyone tell me where am I going on this?
Just like the inequality.
The inequality symbol flips. If you divide or multiply by negatives, is that true? In this case, I divide by negatives, it will flip and turn this into x is greater than. It flips. Only when you divide or multiply by negative. And there's the answer. Now, what does that look like in interval notation? It says everything to the right of -7, but you cannot include -7. Guys, in interval notation, it means it's going to look like this. -7, comma, infinity. You're done. I got just a minute. Are we okay with this one? Now, tell me please, and I'll finish this up after the break. I will set you up. I'd like to just get a little bit of input on this before I solve it at the grade. I'd like to solve this inequality. I'd love for someone to tell me, Professor, I think I see what's going on. Here goes. X squared, subtract 3x, subtract 10 is greater than or equal to 0. This is inequality. I will say, but a little bit, just a little bit of input. Can anyone tell me what's involved here? The way it looks. And how's this tie in with what we've been doing? Why would I do my lecture like this?
It's a quadratic.
It's a quadratic. It's a quadratic inequality. Now what can I do with the quadratic? I can factor. Quadratic formula. Maybe a graph if I wish. Guys, save me a little time. If you want to use quadratic formula, go for it. I'm not going to finish this up completely. I'll do this for you. It will factor x. Lovely. Can anyone tell me the factors? We're back into a quadratic. What does this thing factor? -5, thank you, and +2. Now, if we were doing this as an equation, you saw me do this as an equation earlier, you would just split these up and say, Professor, the answers are 5 and -2. But this one has this attached to it. It's not an equation. It's a greater than or equal to. It's an inequality. So it's a different routine altogether to finish it up. And I'll finish it up after the break. Guys, we'll do a quick count though. Got a 10-minute break. Enjoy it.